Okay, welcome to page 2 of the Unit 6B and 7 review. Okay, so we're talking about finding the derivative of an integral, right? This is the rate of change of the area underneath a curve. That's what an integral is asking us to find. So we can write, and this is kind of the definition, if we have some function that is defined as an integral from a to some function, right? So that's g to where your numerator, where your limit of integration, your upper limit is some type of a function, right, of f of t dt, right, some other function. If that's true, then the derivative of our integral is found by simply, and I say simply, there's some pretty neat stuff in here, taking your upper limit of integration and putting it into your x value in your function, right? So we're using composition and then multiplying also by the derivative of that upper limit of integration. Okay, so this is the, and I say simple, right? You can do it using the fundamental theorem of calculus, the first one, but this is a much more forward and direct way of doing it. So if we're gonna find the derivative here, h prime, right, the first thing we do is we take our limit and replace it in your function. So that's x, the third root of x to the fourth. Okay, so we have replaced t with our upper limit, and now we have to multiply by the derivative also. So the derivative of x to the fourth is 4x cubed. Okay, and now we're going to hit this algebra. So the square root of x to the fourth, hopefully you know as x squared, times 4x cubed, and now we have to simplify. 4 times 3 is 12. X squared times x cubed is x to the fifth. And that is the equation to find the derivative of this integral for any upper value x. Right, so we're going to plug in different upper limits of integration, and that's how we're going to find the rate of change of the area under the curve. Okay, let's do that again over here. Remember, the first thing we want to do is plug our upper limit of integration into your function, so cosine x squared, and then multiply it by the derivative of cosine, which is negative sine. Okay, so we can do a little bit of simplifying. We can distribute that 2 to make it cosine squared x negative of, right, because the negative comes out here, times sine x. Okay, now that's a safe place to stop. If you wanted to, we could use our Pythagorean identity and replace this with 1 minus sine squared, right, and do some distribution and some other things, and we could end up with negative 2 sine x plus 2 sine cubed. Okay, so you might see the red answer on a multiple choice, but the blue answer is fine if you're doing it by hand. Okay, so the rest of these are finding general solutions. Remember, a general solution has a plus c with it, so we don't have to solve for, well, we would have to solve for y, but it's going to have a c in there. Okay, so our first step is to separate. So we're going to switch your numerator with your denominator, and I'm going to leave the 2 alone over there. Okay, so my 2 is going to stay on the right side. So my first, when I separate this, I will have dy over y equals negative 2 over x dx. Okay, remember your x is in your denominator here, so it's going to stay in the denominator, and your 2 is in the numerator, so it stays in the numerator. Okay, so we have separated. Now we're going to integrate both sides. And the antiderivative of 1 over y is natural log of y, okay, an absolute value, so we make sure that we keep it positive. And over here we get another natural log, negative 2 natural log of x plus c. Okay, so there's the antiderivative. Now we're going to continue and we're going to exponentiate. That's how we get rid of these natural logs. Okay, exponentiate them. Make them into exponents. So I have, let's see, absolute value y equals e to the negative 2 ln x times e to the c. Okay, so I'm splitting this into a product of two separate powers, right? They have to have the same bases. So now this is going to become its own constant, right? It's its own constant, some other number e to the c. And I'm going to spend a little time doing a special natural log product, and that is bringing this to the power of your argument. Okay, so I'm going to take this and make it e to the natural log of x to the negative 2 power. Okay, and that's handy because e raised to the natural log, that just cancels itself out, right? I don't have to worry about that anymore. So that's c times x to the negative 2 power. Okay, which is pretty fantastic little thing here, which becomes c over x squared if you want to solve that one all the way down for y. Okay, and because it's natural log, we can have positives and negatives to do there. Okay, I guess we could have also left this, right, if we didn't separate it over here. Sorry, I'm going to get a little crazy. So we could have left it as e to the negative 2 ln x times some other value c. That would have also been acceptable. And I guess you could put the c in front also. So there's a couple different ways that we can write this. Both of them are correct, right? So you're never going to tell what you're going to see on a multiple choice option. Okay, so general solution for this. Here we're going to once again separate your variables. So we have y times dy equals 2e to the x dx. Okay, so let's take the integral of both sides. That becomes y squared over 2, or 1/2 of y squared. And over here, the antiderivative of e to the x is, of course, e to the x times 2, right? So the coefficient stays there in front. 2 e to the x, and then plus c. Okay, so there's nothing else we have to have for e to the x. It is its own antiderivative. It is its own derivative. So now we need to solve this thing for y. We'll multiply everything by 2, right, to get rid of the 1/2. So y squared equals 4e to the x plus some other c value, right, maybe 2 c's, right, and this can be written as, right, I don't know, c sub 2 if you want to write that. So then our final step would be square rooting, and we get plus and minus 4e to the x plus some other random value c. Okay, so you can write 2c in there if you want to, but most often you're just going to see it as a c. Okay, so there are some general solutions. Now we have initial conditions, which we're going to find c first. Okay, so let's talk about separating. The dx is going to come over here. We're going to divide both sides by x. Okay, when we separate these variables. So we're going to start off with y dy equals natural log x dx divided by x. Okay, that's what we get when we separate these variables. So now we're going to integrate both sides, and this becomes 1/2 of y squared. And over here, we're going to use some u substitution. So let u be the natural log of x. So du is 1 over x dx. So dx is x times du. Okay, you got this? We're using u substitution and letting u be the natural log. So u is your new substitution, so u over x times x du, right? When we replace dx with x du, oh, look what happens. Amazing that the x's cancel each other out, and we just have the integral of u du. Okay, so we'll come over here and we'll continue on. We still have 1/2 of y squared on the left side, equals the integral of u du is u squared over 2. So remember, u is natural log. So we're going to have 1/2 the natural log of x squared plus c. Now here we have our initial condition. We have x as 1 and y as 0. Let's go ahead and plug those in. I'm just going to do it very lazily. I'm going to put a 0 here, and y is 0 and x is 1. Okay, so 1/2 of 0 squared is 0. Natural log of 1 is also 0. So c is nothing. That's pretty easy. So we have 1/2 of y squared equals 1/2 of natural log x squared. Okay, so we'll multiply each side by 2. All right, that cancels the 1/2. Y squared equals natural log of x squared. And square rooting, we get plus and minus, I guess, the natural log of x. So it could be either the positive or the negative. But chances are it's going to be positive, I think, in this problem, because we get a positive x1 and y is 0. So we're going to only be looking at the positive values of natural log. Okay, so y equals natural log x. Okay, continuing on, we're going to move the dx over here. All right, so we'll have x dx, and then this is going to be your denominator, so we're going to divide by that. And then we're going to move this one over here and divide by that also. So we're going to have some pretty crazy looking things here for this one. We have y over root 1 minus y squared. dy equals x over root 1 minus x squared dx. Okay, so that's how this problem starts. Algebra, integrate. Okay, so these are both going to be u substitutions. So I'm going to let u be, in both of these cases, the denominators. Okay, we're going to let u be the denominator in both of them. Okay, so I'm going to do that and come right back. Okay, and this is what I end up with. I have y over root of u times du over 2y, which is nice because then the y and the y cancel out. And on the left side, I have x over root x, or root u, and the x's cancel out. Okay, so it's kind of nice that when you pick these as your u values, okay, that your x's and your y's cancel out. Okay, so let's see, what do we have? We have the integral of du over negative 2 root u equals du over negative 2 root u. All right, so on the left side, this is pretty amazing actually. Think about if we took the derivative of root x, right? If this is your f value, then f prime is 1 over 2 root x. Right? Maybe you don't remember that, but that's how it works because we have x to the 1/2 power, right? So you bring the 1/2 power to the front, which is where you get your 1/2 from, and then x to the negative 1/2, which is a root. So the derivative, right, of 1 over 2 root x is actually root x, right? The antiderivative. So that's pretty much exactly what we have right here, if you'll notice, right? Only it's a negative. So this is the negative root of u equals the negative root of u. Now remember, these u's are different, right? The u on the left is 1 minus y squared, and the u on the right is 1 minus x squared plus c. Okay, so we got some pretty crazy things here. All right, so let me rewrite this again. Negative root 1 minus y squared equals negative root 1 minus x squared plus c. So now let's plug in our initial condition, right? X is 0. So I'm going to be a little bit lazy here. X is 0. and y is 1. Okay, so 1 minus 1, this term cancels out. 1 minus 0 is just 1. Okay, so I have 0 equals negative root of 1 plus c, which is negative 1. So c is positive 1. Sure, why not? Okay. Or if we get rid of the negatives here, right, then these are all gone and we have a negative. So I don't think it's going to matter that much one way or another, whether you have it be a positive or a negative. But let's do this. Let's get rid of our negatives first off. So then this is a minus 1. Okay, that's what I think you would have done also. All right, so now, are we done yet? No, we're not done yet. All right, so the last thing is we have to solve this for y. So root 1 minus y squared equals root 1 minus x squared minus 1, right? Minus 1. So we're going to square both sides. So here's the algebra, square both sides. This is where calculus gets hard, is doing the algebra. So remember, it is this thing times itself. So when I multiply a root times a root, I get nothing. So 1 minus x squared, right? Minus 2 of these, 2 of them, 1 minus x squareds, right? They don't cancel out because they're both negative. And then negative 1 times negative 1 is a plus 1. Okay, so I've got all of this stuff going on here. So now I'm just going to minus 1 from both sides, right? And that's gone. So I have negative y squared equals 1 minus x squared minus 2 roots of 1 minus x squared. So now I'm going to change the signs of everything and take the square root. Square root of positive x squared plus 2 roots of 1 minus x squared minus 1. Okay, now we have to decide whether it's positive or negative. So looking back at your initial condition, we want when x is 0, y is to be 1, which is a positive value, so we're going to keep the positive as the answer. So positive root x squared plus 2 roots of 1 minus x squared minus 1. I agree, that's a crap ton of algebra. Whew. Okay, and then the final thing, yes, this is the same. There's a whole lot of algebra here. So rather than taking 10 minutes to explain it, I'm just going to pause, and it's magically going to appear in 3 seconds, and then I'll talk about it. Wow, so there's the answer. And let's look at all of the work that went into it. Okay, so hopefully you can see. We did a u substitution. I let u be 1 plus y squared, okay, over here. And I canceled out some of the y's, and I got a natural log, 1/2 natural log u, so 1/2 natural log 1 plus y squared as the left side. And on the right side, I distributed to make one single polynomial. And then I split that into the integral of 2, my 1 over x, and the x. Okay, so then this became the antiderivative. I used my initial condition and found c was negative 1/2. So with that, then came all the algebra, right? And I solved all of this with all of our exponent stuff, right? So I put the x squared minus 1 together. I used the power property where the 2 in front of the natural log becomes a power, so natural log of x squared. Okay, and I do that so that when I exponentiate e to the natural log, right, those things cancel out. I just get an x squared, right? I just get the argument of natural log. Okay, and then I subtract 1 and square roots, and because it was a positive value, we take the positive root, not the negative root. Okay, so yes, these can sometimes be pretty crazy, right? A lot of algebra, very algebra heavy on this, so hopefully you're getting better at the algebra, because there's a crap ton of algebra in calculus. All right, that's all.